I'm really excited to share with you how we can derive efficiency, but not only efficiency, but also effectiveness for products, AI products, and data science teams. I'm really the effectiveness person, not really the efficiency person, but I try to include both of the principles that can address both of the efficiency and effectiveness. So, quick intro. My background is computer science, data science, machine learning. I've been working in this area for the past 10 years. And I worked for different organizations, including National Research Council of Canada and Microsoft Research. And I joined Georgian around 4 years ago. And I had the pleasure of working with different technical teams, startup companies, and entrepreneurs. It might be useful that I give you a quick intro and provide more context about Georgian. We are a fintech platform for growth stage funders and CEO. Basically, we are a VC, and we do everything that VCs normally do, but we go beyond what VCs do, and we try to disrupt our industry. We have more than 2 billion under management, which is a pretty big deal for Canada. We are the biggest private fund in Canada, around 60 employees and headquartered in Toronto. So what does it mean that we provide capital and go beyond that? We have a vision, and my team mainly has this vision of providing and driving innovation and research for our startup companies. If you think of any big organization, a tech organization like Amazon, Microsoft, and Google's of the world, they have access to talent. They can invest in research, and as a result of that, they have a much better position in the market. So we have a similar vision. We want to be an applied research lab for our portfolio companies, startup companies, to de-risk the investment in emerging machine learning techniques to overcome business challenges at a scale. And of course, we can help them to adopt these transformative technologies to drive product differentiation. Having said that, our research team has been focusing on various research areas, including and not limited to representation learning, transfer learning, AutoML, and of course, trustworthy AI, privacy and compliance, explainability, and fairness. We also have toolkits available in a number of these areas, and they are all open source. So check out our website or our GitHub to learn more about the available open source libraries if you're interested in any of these research areas. Moving on to our principles to drive efficiency and effectiveness for data science teams and machine learning products. Of course, critical to the success of any product development process is having a clear definition of the value that machine learning will deliver. Whether it's an automation, augmentation, scale, increasing the quality, or even consistency of a business process, we need to define the value prop. And after we have defined it, we need to make sure that every single stakeholder have a clear understanding. And by stakeholders, we mean business owners and customers, and even the technical team who are actually working on this product or project. Once everyone is on the same page, we need to define a clear end state that is attainable, feasible, and of course is in line with the value prop that we defined earlier. And then it's really important to understand the difference between more traditional software development and machine learning and AI development. Data scientists need to have access to customers and business leaders and business owners to make sure that they are staying on the problem that matters. Because often we saw that the technical teams get lost in the shiny technologies, and it's really important to have that kind of access and validation from different stakeholders. We normally start our applied research engagements with a quick AI workshop to identify opportunities for machine learning and AI and evaluate these opportunities against their effort and, of course, value. It's a great exercise. It doesn't need to be a one day. It can be a couple of hours exercise, at least to make sure that you have the full alignment and every single stakeholder understand the value and understand the investment. After we identified the opportunities, we have a plan in place, we have a roadmap in place, but we need a team to execute on that. Again, common mistake in building data science team is that you believe it's enough to hire a bunch of data scientists, give them the data and ask them to do whatever is possible based on this data. So it's really important, and it's really important to highlight the skills that are required and, of course, experiences that are required to have the successful AI team. We need product management. Again, it's a top-down problem rather than a bottom-up problem. We need data engineers because it's now even more clear that if you don't have the right data foundation, if you don't have a data that is usable for machine learning purposes, data scientists can go nowhere by focusing on the technology and optimization. And of course, you need software development and quality assurance. Software development, of course, to deploy and productionizing the machine learning systems and understanding the integrations with the current code base. And quality assurance, it's also super important. I'm gonna talk more about quality assurance in the later principles as well. And it's, again, maybe software development 101, but I guess often it's neglected in AI development that you need to have documentation and cross-training to avoid the bottlenecks. And of course, we learn it in a pretty hard way that we shouldn't isolate research and production teams. We need to have squads or pods of engineers and scientists that work together since day one. And the last one, but not the least important, of course, not least, recognize and celebrate diversity. What will drive innovation, drive differentiation, and make any AI team super successful is diversity of thoughts. So embrace diversity of thought when you're building your AI team. Quick overview of all the skill sets or different roles you can have in your AI team. We have also published our white paper. You can check our website and learn more about our framework of the team structure. So, given that we have a pretty diverse audience tonight, it's really, really important to reflect where you are in your maturity in AI. Where is your team? Whether you are just exploring and trying to understand and quickly prove the value of ML business model of the ML to the business, or whether you are at a scale that you have a pretty big team and your team is focusing on a diverse set of problems. You might need different types of and different processes for software development and machine learning system development. Plan for experimentation. AI experimental is messy and expect lots of failure along the way. I guess AI product development is very close to academic research in many ways. This means that you will be overseeing experiments kind of like a principal investigator. So it might be useful to actually use a formal experimental design framework, starting with idea generation, testing, refinement, and rejection. And of course, it's really important to have an agile mindset. And by having an agile mindset, you don't need to only have the acceptance criteria, but you also need a stopping criteria to not get emotionally attached to a method or outcome and can quickly move on if a solution is not working. I really like this. It's one of many different frameworks that has been developed for documenting the experimentation, and I really like it because it has a clear metrics definition, and it also explicitly states what actions to take at the end of the experiment, whether if it fails or it passed, what are the next steps, what are the next action items. Also, it's very, very clear, because I often again found data science teams to get lost. They really don't have a clear understanding of why they are running these experiments, and based on the outcome of the experiments, what decisions or action items they're going to take. It might be worse if you're interested. I'm going to respect the time, your time, and of course screen fatigue. But check out Teresa Torres' experimental design questions. I'm sure you're going to find lots of good insights. Principle number 4: plan for deployment and continuous quality assurance. And I can't emphasize how important it is. Why? Because I have seen many POCs that never get to the production because the team didn't think about the integration at the beginning, because the team didn't consider the deployment environment and deployment requirements and constraints. And then, of course, don't throw a model over the wall. Foster collaboration between data scientists and engineers throughout the process. Again, it's really important to have the pods or squads of engineers and scientists working together. And keep in mind that a machine learning model can't be built once and left alone. As the real world changes, so will the underlying data, and of course the performance of your machine learning systems. So it's really important to plan for continual care and feeding to keep these machine learning models in good shapes. Then you need to have a clear accountability and ownership. Who owns this continuous model care and feeding of the machine learning models on continuous basis and ongoing basis? QA is a very quality assurance for machine learning models. It's a very, very interesting topic. I'm really encouraged that the community now spending more time to understand the deployment and of course quality assurance. And the reason it's very complicated, or it's because it's different. We are dealing with probabilistic models rather than deterministic systems. And we might never get to 100% accuracy. So that's another challenge. That's why it's very difficult to test these models. So maybe, I guess both of you have heard about the ML operation, and how we can use ML operation as a framework to deploy, monitor, and maintain your machine learning systems. I really like ML ops, and because it's more about how we can take into account the people, skills, and processes that need to successfully launch, test, and maintain a machine learning system in production. We have also recently open sourced our own machine learning platform. Again, if you're interested, you can find it. You can find our open source toolkit in GitHub. And I really like maybe to pointing out to what can be a machine learning surprise. When you start a project, often data scientists believe that they're gonna spend most of their time on optimizing the ML algorithms, but it's not the case in reality. In reality, in real world problems, and of course, at least based on my experiments working with the startup companies, you spend lots of time in collecting data, cleaning data, building the infrastructure to deploy your machine learning models, and of course, integration. So it's really important to think about these types of challenges at the beginning and allocate time and resources to address them. Don't reinvent the wheel. There will be always a question of build versus buy. And it's really challenging, I guess, for machine learning teams because our field is rapidly evolving, both AI best practices as well as commercial and open source libraries that are available to make the data science teams more efficient. So make sure that you always stay tuned of what's happening in the community and understand the rapidly changing landscape, and be flexible. Be flexible and open to disrupt your roadmap, plans, and processes. Why it's really important? Because you can always build on top of what is available, and it's really important to always think about what is your own differentiation and what you are in a unique position to build versus buy. This is the current landscape of AI and ML tools, and of course, it might not be the same in the next 2 weeks or even next month. So it's really, really crazy. So no matter of how you are using AI, you most likely be able to build on existing tools, from infrastructure to algorithms, commercials and open source solutions, or even open source machine learning models or pre-trained models. So be resourceful, especially if you're working for a smaller organization. You can't really afford to build everything from scratch. And the last principle, minimize spend on cloud infrastructure. I learned it in a pretty hard way that some of our companies, they spend half of their revenue in cloud environment and and hosting costs, and it's terrible. It can have terrible consequences for the business. And of course, the data science teams. So start with pre-trained models if it's possible. Use compression techniques when necessary. If you have a huge BERT model, try to understand if you can use compression techniques, especially to reduce the cost of inference. And developing and training machine learning models can be also more efficient. First of all, use the simplest technique that can do a large part of the job. I know as a scientist, I also often get excited about the technology, while there might be much easier method that can do the large part of the job. For example, we don't need to necessarily solve every single problem out there using deep neural networks. There might be logistic regressions and XGBoosts of the world out there that can do a pretty good job. And then leverage tooling to track experiments. That's also another challenge that lots of our scientists, especially when they are dealing with large experimentation, large deep neural network experimentation, they are dealing with. And hyperparameter tuning is another challenge that can introduce lots of cost. So again, use technology, use the optimization techniques or open source libraries or even commercial tools to get more efficiency out of your hyperparameter tuning. So don't forget to monitor the cloud cost. And here I have the most commonly used data science frameworks, but my goal is to make it clear that, again, this is the current snapshot. Tomorrow it might be different. You have to stay flexible, but at the same time resourceful, and try to understand which of these frameworks might drive value, drive efficiency for your team.
what would you say the biggest challenge is when your partners, I guess, that you've invested in, when they come to you and say, hey, we want to hire a data scientist or a data engineer? What are some of the challenges that they're facing, and kind of the common maybe mistakes that they make in hiring for these types of
Again,
roles?
you have to have a very clear understanding of where you are in your maturity in machine learning and data science, and what are the most important hiring and what are the most important initial roles that you need to fill. For example, if you bring in two data scientists without having any engineering support, it's such a mistake. And then if you bring an engineer without any like two engineers that or and a scientist, but without having a product management or someone with product mindset, again you are setting the team up for failure, because you need to have someone with a clear view over your customer requirements, user interface, the integration, and the kind of business metrics that you need to optimize for.
Yeah, no, that's great. I see a lot of clients. I feel their mentality is like, oh, let's get into data. Let's just get into it, and we'll hire a data scientist. And like, oh, we're in it, guys and girls. That's it. And that's probably why there are so many problems and challenges. Is that they just kind of hire one person and think that that's it, it's done. So yeah, really interesting insights there.
I think the first question that we have is from Kritika, and she asks, what do you suggest that an ideal ML model should be like?
An ideal ML model.
Yeah, I'm not exactly sure in what way, but that's what she asked.
There is no ideal ML model, so there is nothing is ideal in a probabilistic work. So, and again, that's what we have to learn. That we have to have this kind of mindset shift from deterministic to probabilistic kind of systems. That nothing is ideal. It's always about we can predict the probabilities or likelihood of certain events, but it's not going to be perfect. Of course, as humans, we have this tendency to map everything to our deterministic thought framework. And it's okay. We can come up with a threshold. If the likelihood of an event is above a certain threshold, we can call it event X. If it was below, we can call it event Y. But it's not definitely the error of the system. It's more the error of our mapping a probabilistic framework to a deterministic decision making.
Way to go.
Yeah, absolutely. And I think it's very iterative as well. So, you get better as you move forward in the process, which it, brings us to this question, the question that is asking about, before starting to build an ML model, would you suggest any techniques to build a quick and dirty baseline model to compare against?
Sure, like logistic regression and XGBoost are your friends. Okay, so then also, and again, it depends on type of data, type of problem. For example, if you are dealing with NLP or computer vision types of problem, then you have to spend lots of time on feature engineering, and you might start with a pre-trained model. Again, that can take you somewhere. Like for example, if you are dealing with an NLP problem, Hugging Face recently released their zero-shot learning. It's perfect to start. You can just use Hugging Face and just use their zero-shot learning. Even if you don't have any training data or any label data to train your system. It can be a great baseline. And then, because if you have a computer vision, I guess there are also lots of open source machine learning models for computer vision, for image classification, segmentation, and problem like that. If you have more traditional structured data, then definitely XGBoost and logistic regression.
Yeah, that's a really good point. And back to the question, cheap and dirty solutions at the beginning are always the best ones because you're not spending a lot of money and time and effort into them. And then from there, you can actually take it off and do more experimentation for sure. Jessica, one of our audience asks, are there signs you can notice during earliest stages that you haven't taken the appropriate steps in the beginning?
Yeah, of course. Like most of the time, if you haven't invested enough in your data infrastructure, data layer, you don't have data that is usable for machine learning models. So either you're getting very bad performance, or you're getting surprisingly great performance, something around 90% accuracy, which is again so good to be true. And you have to make sure there is no information leakage or data leakage, because most likely that's the case.
So another question is a really good one. It's very close to our heart, at least my heart. So many companies expect just one person to know everything, like development, machine learning, data engineering, QA, etc. How can one apply for a job in this case?
I know, it's crazy. It's crazy. We are expecting everyone to be a ninja, and it's not the case. There are not as many ninjas out there. So if you're hiring or if you're in the job market, make sure that even when you're reading the job description, even if it doesn't apply 100% to you and your background, just keep apply. Even if it's like 60 to 70% applicable to your experience and background, apply. And I have also this discussion with my team as well, like what is the most critical? So have a priority list. What is the most important for this person to be successful in this role, and what are the areas that we can train, and we can provide training and support for our new employees. For me, for example, ML ops is completely new topic. If a person that I'm hiring doesn't know enough about ML ops, is completely okay for me. Given that I know spending a few months, if you are dealing with a smart, curious, excited, and passionate individual, they can definitely educate themselves. And also share your passion and your learning and development plan with the employers, and they will definitely appreciate, even if you are not 100%, if you can check all the kind of items that they mentioned in the job description.
Yeah, so Alex is asking, what do you think was instrumental in your success in becoming a leader in AI? Maybe what sort of advice would you give yourself like 5 years ago?
Very cool, very good question. I guess I never wanted to be a leader. I never wanted to work on a very hot topic. I started working in this area of machine learning and data science more than 10 years ago. And I raised and grew up in Iran. So back in Iran, when I started working in this area, it wasn't by any means hot, or even any of us could have any sense that it's going to be the next hot thing. So I guess what really derived success, if you can call it success for me, was like my passion for solving problems, and of course using any tools out there, which I found machine learning to be the most efficient and effective tools out there to solve problems at scale.